All right, welcome back, everyone. Do we have any new people in here this week? Shut up, Wasabi. All right, so one new person. Welcome to Unallocated Space. Have you been here before?
I have not.
So Unallocated Space is a like a tech community, hacker space, maker space. We give classes. People come out. They'll hang out. They'll work on their projects. There's a lot of people here to talk to get help with your project. And we also appreciate it if you put your input into the space, like provide what you know to other people, help them out as well. We're a 501c3 nonprofit organization, so any of your donations are tax deductible. If you make a cash donation with like a receipt, please use an envelope to put it in the donation box and talk to a key holder or board member. I am a key holder. Buddy is also a key holder. I don't think we have any other key holders in here tonight besides all the way in the back, Comp Mage. He's under the loft, though. There's drinks in the fridge. Unfortunately, we're low on water today. And other than that, welcome. My name is Corey. Have you seen any of the live streams or anything like that from the previous classes? All right. Are you familiar with GQRX?
Yes.
All right. Are you familiar with GNU Radio Companion? All right. Tonight we're going over GNU Radio Companion and how to use it. Who has done the homework from last week? All right, it's better than none of you, I guess. And so my hope with that, with the homework from last week, was that you would I'd ask you what is POCSAG, and I hope from there that would lead you down this rabbit hole of some pretty fun stuff you can do. And basically what POCSAG is, it's a pager protocol that's unencrypted. There's a lot of these transmitters in the area where you can just pick up the information and get it to come out as clear text on your screen. Has anyone in here done that? Picked up these POCSAG pager transmissions? Did you see some very interesting stuff in those transmissions? Stuff that you felt like should probably not have been in clear text on the air? So according to the SIG-ID wiki, POCSAG is a one-way 2FSK, which means two frequencies, frequency shift keying, paging protocol, runs at several different baud rates. Most commonly you'll find it at 1200, a little bit less commonly you'll find it at 512, and very rarely you'll find it at 2400. Like it says, commonly used for pagers. Some amateur radios use that protocol as well. And 99% of the time it is unencrypted. And for those of you that have pulled down the transmissions, you may have seen a lot of HIPAA violations, HIPAA being the act that protects your private medical information. A lot of doctors use these pagers, and they will just, out in the open, put your name out there, put social security numbers out there, put all sorts of stuff they should not be putting out there on the air. Yes, question in the back. So the question was, are these like the pagers from the 90s? If your 90s pager could receive text messages, then yes. Also, there are times where it's just a phone number sent over these, so likely that's what the early 90s pagers would pick up. Cell phones do not pick up this quite as much. There might be a cell phone or two out there that has this capability built in. What frequencies are you likely to find it on? I asked specifically in Maryland, but it basically applies to anywhere in the United States. The answer is there's a lot of different frequencies. There's stuff down almost the HF bands, like in the 40 megahertz. The place I usually look is between 152 and 154 megahertz. That stuff comes in pretty strong. There's a hospital around here, I think Glen Burnie, that transmits it pretty strongly. And then there's a lot of stuff in the UHF frequencies as well, so up around like 150 to 160 megahertz, and all the way up in like the 900 megahertz as well. If you go on the sigidwiki.com and look up POCSAG, there's a whole table there that tells you all the different frequencies for all the different countries. There's also this great website called radioreference.com, and basically if there's some frequency that's occupied for some reason in a particular area, it will get posted to Radio Reference, and it's basically like a little database you can go and look up. I see this signal on this frequency, what is it, type of thing. And then I asked, what Linux program can decode these messages? The answer I was looking for was Multimon NG. Does anybody else have a different program that works on Linux?
I use PDW under Wine. It works fine.
Yeah, PDW is the common program for Windows. Usually you'd use that with like virtual audio cable or something. It's actually a pretty nice GUI. Apparently since it works fine over Wine, you're welcome to install the PDW GUI. Multimon NG is a command line application, which means you have to run it from the pretty little purple screen we bring up with Control-Alt-T. You have to install it from source, which means it's a little bit more of a pain in the butt to get. I don't even know if I installed it on here or not. I did not. And then it'll decode many different FSK or frequency shift keying type modes. It has a mode on there called UFSK. I have no idea what the U stands for, but it's just like a raw decoder. It'll take in whatever FSK signal you feed it, and as long as it's around 1200 baud or 1200 bits per second, it will spit back either raw hex or ASCII if it picks up something intelligible. It's great, but if you're getting a lot of noise, there's a lot of crap to sift through before you find what you're looking for. And then it has the specific POCSAG decoders, specific AFSK 1200 decoders, and those, you kind of need to give it a pretty strong signal for it to pick out the information. But the bright side of that is you don't have to dig through any crap to find your message. And then just like FLDigi, QSS-TV, or any other program we use in here, it takes an audio stream from some program like GQRX. Any questions on any of those pieces of software? For the CTF next week, I highly encourage you to try and install that Multimon NG program. And if not, that PDW program apparently works well under Wine. All right. That's it for the slides tonight until I give you the homework later on. Tonight we're mainly going to be doing a hands-on Gnu Radio tutorial. So we'll be going through, looking at a few different blocks, seeing what the different data types are. And then by the end of the night, hopefully you'll all have a working wideband FM receiver. Sound good? So if you already have GQRX open, please close it. You will not be using GQRX tonight.
What?
So to open GNU Radio Companion, we're going to open our terminal. For those of you on Ubuntu, remember Control-Alt-T. And if you're not on Ubuntu, you probably already know what you're doing with Linux, so find your terminal program. Now since you have GQRX installed, that should have automatically installed GNU Radio with it. To open GNU Radio Companion, which is a little flow graph program we'll be using tonight, if you just type GNU Radio-companion and hit enter, it just take a minute, but it will load up. And you should be presented with a screen that looks like that. Is anybody having any problems opening GNU Radio Companion? Anyone still working on opening it? All right, I'll give you all a minute. Those of you that were still trying to open it, is it open now? Roger, you doing okay?
Yeah. Right round, put down. GNU or UDIO companion.
And there's no space in that. Close your GQRX. Yep. So what we're going to start off with, just a couple of basic building blocks. We're going to take a signal source. We're going to get some sort of FFT display, some sort of GUI. And we're going to feed that signal source into the FFT. So that'll give you an idea just how to connect the blocks. And then from there, we'll start pulling in data from the RTL SDR. We'll play around with some of the sample rates, a couple other variables. And eventually, we'll just keep adding more and more blocks until we have a working wideband FM receiver. Roger, are you good? Cool. All right, the first thing I want you to look at on this page is this block that says options, an ID top block. Whatever you name this in the ID is going to be the name of the Python file that it creates. GNU Radio spits Python out the back end of it. So I'm going to call that WBFM-receiver. And it's not happy with that. See how this ID turned red? If GNU Radio is not happy with something, if there's an error, it will highlight something red, let you know something's wrong with it. And then if you look down in the bottom here, where it says param-ID, it tells you what the error is. And it tells you that it must begin with a letter, may contain letters, numbers, and underscores. So do you see something in here that's not a letter, number, or an underscore?
The dash.
Yep, so it is not happy with the dash, so what I'll do is I'll just go over to that, and I'll replace that dash with an underscore. Title is whatever, when it's going to open some sort of window, and the title is whatever the name of that window is going to be. That can have spaces, that can have special characters, that can be whatever you want. Author would be your name. Description, just tell you a little bit about it. Canvas size, that changes the size of your working space back here. You can play with that if you want. I'll leave it blank. Generate options. Right now this says Qt GUI. Another option is WX GUI. Those are two different GUI libraries, I guess you can say. GUI is graphical user interface, for those of you who don't know. It gives you basically something to look at, something to click. In here we'll be using the Qt GUI. WX GUI I like a little bit better, but on some systems it works really well, and on other systems it'll fight you to the bitter end. There's kind of no in between with that. Qt GUI I found works pretty much all around. Then there's also no GUI if you want to just make a command line program. And then these two, don't really worry about those. But just leave it at default Qt GUI for now. Everything else you can leave at default, hit OK. I'll give you all a minute to play around with the options block. All right, is anyone still trying to mess with the options block, or are you all good on that? All right, cool. Next thing I want you to look at is this variable called samp underscore rate. That is the sample rate you'll be working with in your program. By default, it sets you to 3200 kilohertz, but that's, for most things, that's not really useful. For just playing around with the blocks, that'd be all right. What I'm going to do right now is we're going to call it audio underscore samp rate. So just put the word audio and then an underscore in front of samp rate. And then that value, right now it says 32,000. I want you to change that to either 48,000, or there's another way you can type that. It doesn't help so much with smaller numbers like this, but when you get into the millions, it'll help a lot. You can backspace those zeros, put 48, and then E, which will then notate some sort of scientific or engineering notation, and 3. Basically, all that's saying is 48 times 10 to the third, or 48,000, or 48 kilo. And from there, hit enter. And okay, I should have closed the block, but it didn't. Okay. So now you notice it says value 48K instead of 32K. So again, you could either put 48E3, or you can put 48,000 or 48,000. Okay, so how many of you in here, when you're searching around a PDF document or trying to find something in a Word document or find something on a web page, do you scroll through forever and look for the thing, or do you hit Control F and type whatever you're looking for? Yeah, well, Control F is a wonderful thing in Gnu Radio also. So over on the right-hand side, you see this long list of drop-down menus. Those are all Gnu Radio blocks, and they're all useful in some way, shape, or form, depending on what you're doing. But really, we're just going to be looking for a few different things. So I'm going to hit Control F, and you'll notice it brings up a search bar up here. In that search bar, we're going to type signal. Now notice, as soon as I type signal, I don't have to hit enter or anything like that. It instantaneously updates the list and makes it much smaller. And then afterwards, signal, hit space. And even when I hit the space, that immediately updates the list, makes it even smaller. Signal source. So what we're going to look for in this block is something called, or in this window, we're looking for something called a signal source. And this narrowed it down to literally one option when we use the find function. So if you click and drag the signal source, okay, you just click, drag, drop. If you're having trouble finding it, please let me know. How many programmers do we have in the room? So any programmers in here should know what an integer is, what a floating point number is, basically any data type like that. Or if you're a programmer and you know what an int is, but you have no idea what it means, I don't know how you made it through your programming career, but an int is an integer. And the reason I asked it is because just like programming, GNU Radio uses different data types. Notice how there's a little blue rectangle on the end of this box. And if you hover over it, it says out. That little blue has a meaning. It lets you know that that is a complex number. If you come up to the top where it says help, and you click help, and you click Types. For those of you that are not colorblind, the color lets you know the type of data that block is either outputting or inputting, or outputting or taking in. So currently this is some shade of blue that happens to match this shade of blue on top. So that block outputs a complex float that's 32 bits. Who in here knows what a complex number is? So basically, complex number is that IQ data like your RTL SDR has. And then you also notice down here in the orange there's a float 32 that's not complex, and that is just a real number. There's no imaginary component to that. So that would just be the I in your IQ data. Did anybody have trouble finding this type's color map? Is anybody in here colorblind? So when you look at this type, how much of this is indistinguishable to you?
Few of them are really close together in color.
For the not colorblind people, a few of them are really close together in color. Like the complex float 32 and the float 64, they're both blue, just one's a little bit lighter than the other. Integer 32 and complex float 32 are also extremely close in color. So once you get the signal source out here, double click that to open it. First thing I want you to look at is output type. Right now it says complex, which is why that has the blue output. Select that drop down menu and click float. And when we click apply, so as soon as you click float, just click apply, you'll notice the color of the output turned to orange. So now it's going to give us a real number rather than a complex number. Waveform, cosine, you can leave that alone, but it has a bunch of different options. But again, please leave it at cosine. Frequency is in hertz. So right now, by default, it is set to 1,000 hertz. We'll leave that alone. Amplitude 1 and offset 0. You again just leave all that at default. Now you'll notice that sample rate is highlighted red. Now if we come down and look at our errors, parameter sample rate, value samp underscore rate cannot be evaluated. So you programmers in here, what does that mean when a debugger tells you that some value cannot be evaluated? Yeah, it means that that value is not defined. You didn't put it anywhere in your program. So before, what did we do to the variable called samp rate? We renamed it to audio samp rate. So over here at samp rate, just in front of that type audio underscore rate, or audio underscore samp rate. Click OK. Now we'll come back to our search bar.
Are you still orange when you're blow up?
Yes?
Okay.
Okay.
I can't tell what color it's on the board.
Oh.
Well, on that screen, it's not very good.
Yeah, our projector is not good at red.
Open up another browser. Watch it live.
Yes, please use all the bandwidth of my live stream while I'm trying to upload. All right, so now you'll notice that the signal source up here, that's red right now. The block is not happy. And the reason the block is not happy is because it's not connected to anything. It's just there by itself. And GNU Radio blocks don't really like being lonely. So we're going to give it a friend. And that friend is going to help us see that signal that we're generating. So I want you to type in the search bar Qt space GUI space sync. You should come up with one result that says Qt GUI sync. I want you to drag and drop.
Sync with an eye. Sync.
So in GNU Radio, a source generates data or supplies data, and then a sync takes in data. So I can later we'll work with an audio sync, so that just syncs data from GNU Radio into your sound card. There's syncs that let you send data to your radio, not so much your RTL SDR because it's receive only, but if you have a hack RF, you can sync data to that. There's null syncs, which just send the data to nowhere. And in this case, we have a Qt GUI sync, which is going to give us a few different, it's going to give us like a FFT display, it'll give us a waterfall, it'll give us a few different ways to look at our signal. Now, right now, again, double click that. Where it says bandwidth hertz, and it says samp rate, that's red, that's not happy. And it's the exact same reason the signal source was not happy. Samp underscore rate was not defined. So we'll go in, we'll type audio underscore samp rate. Everything else you can leave at default. Click OK. Then what I want you to do is hover your mouse over the output of the signal source. When you hover your mouse over it, the word out should come up. Click on that. Don't drag, just click once. Then come over to the input of the Qt GUI sync. Again, when you hover your mouse over it, the word in should pop up. Click on that. And when you do that, a line should come up, and the tip of that arrow should be red. And when I say should be red, I mean that's what I expect you to see. That actually means there's an error. Anyone in here know why we're getting an error? Yep. So our data types do not match. The signal source is creating a floating point number, a real floating point number. The Qt GUI sync right now is expecting a complex floating point number. I want you to click once on the block so it's highlighted with blue border. And just hit your down arrow once. On the Qt GUI sync block. Yep, just highlight it so the border is blue. And then hit your down arrow. And when you do that, the red arrow should turn to black and your input should turn orange. Yep. It's just a quick little shortcut to change your data type.
Does that just change the data type, or
Yep.
changes whatever it's unhappy about?
It just changes data type.
Go back up to Qt link, click the box. No, not click that. Click like the full box. Full box. All right, now use your up and down arrow. See, it doesn't matter how much bandwidth you put.
All right, so now nothing else should be red in here. Does anybody still have red in their diagram? Does anyone that's colorblind want their diagram checked by somebody else to make sure there's no red in your diagram? All right. So how many people have a green play button up at the top?
No.
How many people have a set of gears?
No.
How many people have something other than a green play button?
Black play button.
Dark gray.
You're not going to find all the magic you want on this.
So if it's dark gray, that means you have error somewhere, and you probably have red in your diagram.
It's just different than yours.
Oh, huh.
Yeah.
Okay. This is about the third time GNU Radio has changed the execute button. It used to be a set of gears, then they changed it to the green play button. Now apparently it's a black play button.
I think mine's an older version probably, because I've had this for a year or two.
So is anybody's grayed out, like you can't click it? You're, oh yeah, that's normal. But as long as you're able to click that, you should be good to go.
Yeah, it's clickable, it's gray. See, I can like
I click it.
Oh, yeah, that's because they changed the, that's fine. That's the next step. When I say grayed out, I mean disabled, like unable to use it. So go ahead and click your play button, no matter what color it is, as long as it's not disabled. And you're going to get a little save the flow graph screen. Saving your data is good, you don't want to lose it. So give it a name that's useful to you in some way, shape, or form. So I'll just call it WBFM receive because eventually this is what it's going to turn into. And you hit enter to save it. And then you should get some little screen that looks like this. Go ahead and make that. Apparently not. There it goes.
I got a warning.
Warnings are okay. Errors are bad. How many people's screens are doing this right now? Turning gray and your computer is locking up? If your computer is an absolute champ, like gaming laptop, you might be okay. It might not lock up. Or it might just take longer for it to lock up. This computer is not so much of a champ, so it locked up pretty quickly. So if it's not so frozen that you can't close it, you should be able to get this little force quit button. Or just wait for it to eventually crash. Does anybody have any idea what happened there? So GNU Radio, sometimes if you're not syncing to any sort of device, so the sample rates basically only matter if there's hardware involved. So the sample rate matters if you're going to your speakers. The sample rate matters if you're pulling data from some sort of RTL or other SDR device. Otherwise, it doesn't really care what your sample rate is. It's going to try and run that data as fast as it possibly can through your system. But there's a way to fix that. There's a way to keep everything from freezing up and dying on you. So I want you to click the arrow that you have connecting your two blocks. Just click it and then drag it down and it should disappear. So everyone broke that little arrow. So over in your little search bar, I want you to type in throttle. Once you have a throttle, click and drag that over in between your two blocks. So does everyone's diagram look similar to what's on the screen right now? Yeah, you can go ahead and connect them if you want. Now, of course, when you connect everything back together, you get two red arrows. So you know the little trick I taught you before with the down arrow? Just, again, highlight your throttle block, hit the down arrow once. Yep. But you'll still notice the inside of your throttle block is red. And that's because it's not happy with sample rate. So go ahead and put audio underscore sample rate. Everything else can be left as default. Hit OK. What's wrong with Savvy?
I'm grayed out.
Okay. Like your whole screen just went gray?
No. Like my play button's grayed out.
That's good. Play button's grayed out when you have errors.
Should be clear.
Do you have any red in your diagram at all anywhere?
I didn't want to change my audio. I'll figure it out.
Okay. Is anybody else having problems right now?
It's not working.
some strange weirdness going on. I've got it set.
Oh, see see how those are two different shades of orange between your throttle?
Yeah,
and
they
your-
both say float. 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 Float.
Open throttle and hit that drop down.
Your complexion float again. Toggle.
It's a darker color.
So it's expecting a 64-bit float for some reason. I don't want to blame Windows right away, but that's the only thing that's different between yours and everyone else's.
It's all compiled in the same. It shouldn't matter.
Oh. Well, for most people, it should have either crashed or they would have been forced to close it in some way, shape, or form.
Only that one. No? You would think that if everything's compiled.
No, I understand. I'm with you there.
Well, let's try this. Let's go to complex, just for shits and giggles.
Oh, so yeah, it's expecting all 64-bit stuff. That's weird. I have Gnu Radio installed on my tablet at home, this Windows. I'll have to try and play with that tonight. Okay, is anyone else having trouble where the throttle block just won't go to like a normal float type? It's expecting like a 64-bit float instead. All right, so once you have this issue solved, just go ahead and click your play button again. And then it should be able to run without freezing up on you. And if this still freezes up on you, I don't know what would be going wrong with your computer.
What does constellation display mean?
So a constellation plot basically shows you the IQ data. So if we're using complex numbers, which we'll switch to that in a little bit, you'll get a circle there. And then when you're looking at an actual real-life signal, the constellation plot can actually tell you a lot about the modulation type. So an amplitude modulated signal would kind of give you just like this complete blob of blue dots like that. Frequency modulated signal should just give you a circle. And phase modulated should give you two clusters. Or if it's BPSK, it'd give you two clusters. If it's QPSK, it'd give you four clusters.
That's cool.
But we'll talk about that more in a little bit. All right, so now everyone has a screen that looks like this. Anyone not have a screen that looks like this? All right, cool. So now I want you to notice something here. You have two different peaks. If you look at this, the center frequency on your FFT plot is 0. So now it's showing you plus, it's going all the way up to plus 22, I think, plus 24. So it's going all the way up to plus 24 kilohertz, and it's going all the way to minus 24 kilohertz. So basically, since it's a real signal rather than a complex signal, it's going to be symmetric on both sides of that plus and minus. With complex, we can make it different on each side. With the signal source, it doesn't really work that way. But for now, there's really nothing you can do with it. It's there, looks cool. But let's make it so we can change the frequency. So again, close that out. Just hit the X. You shouldn't have any problems that time. It shouldn't make you force quit it or anything like that. So we want some way where we can change the frequency. So Qt GUI has a few different ways to do that. So in the search bar, I just want you to type in Qt GUI and leave it at that. So now everything that's there should start with the words Qt GUI. The first set of stuff you see will be under the instrumentation block. You could just go ahead and hit the little arrow to close the close the instrumentation block. So now everything you should see should be under GUI widgets and then Qt, and there should be a bunch of Qt GUI fill in the blank here. So if we wanted a way where we can in the program change what we're trying to do, we can put a checkbox in there, but a checkbox for each frequency that we're trying to play with, probably not ideal. We could put a chooser in there, which is like a drop-down menu. Again, probably not ideal. There's Qt GUI entry, which gives us a little text box so we could type the frequency in directly. And then there's a Qt GUI label, doesn't really help us. Qt GUI push button, again, doesn't help us. And then there's something called Qt GUI range. The Qt GUI range is cool because it gives you a few different GUI options. So it can give you the little text box, just like the entry. It can give you a slider to play with. It can also give you a knob to play with. So there's a few different things. So that's what we're going to use. So go ahead and click and drag the Qt GUI range into your window. And you'll notice there's no inputs or outputs to this block. So it basically creates a variable. Double click it to open it. Now the very first thing I want you to look at is the ID. That's a really long name, and you probably don't want to type that all over the place. So we're going to change it to something really simple. Just going to call it Freq, F-R-E-Q. If you want to be more verbose, more descriptive, you can call it frequency. If you want to be extremely verbose, you can call it audio frequency. But for simplicity's sake, I'm just going to call it Freq. Label, since it's making a GUI element, you get some sort of label to go with it. And that label is just something in the GUI to let you know what you're looking at. And I'm just going to type frequency. You can leave it as a float since we're working with all floating numbers. Default value, we'll set that to 1000 or 1 kilohertz. We'll have it start at 0 hertz. And since we're working with a 48 kilohertz sample rate, we'll let it go all the way up to, now we get really fancy with it. We can make it do some math since it's using Python. So I'll say audio sample rate divided by 2. So what's going on there is you're telling it to take the audio sample rate, so 48,000, and divide that by 2. So now no matter what you change your audio sample rate to, it'll always be exactly half of that. So if I made a mistake there, I put that in the stop instead of the start. Oh wait, yep, that's right, never mind. I did not make a mistake. Now where it says step 1, that's basically what kind of increment do you want this to go by. So you want it to count by 1s, you want it to count by 10s, hundreds, basically whatever number you want to put in there. We'll leave it at 1. And where it says widget, you can do a counter plus a slider. A counter is the text box that you type into, by the way. So you could have it just be that text box. You could have it just be a slider, or you can have it be a knob. I kind of wish there was a knob plus counter option, but there's not. But it's open source, so you can probably add that yourself if you'd like. But we'll just leave it at counter plus slider. Everything else you can leave alone. Hit OK.
Slide, then okay.
Say it again.
Slide, then okay.
If you just hit OK, it automatically applies it, as long as you don't hit cancel. I'm going to leave this window open up for you for a bit. I'm going to take a quick break. Does anyone still need this window open? Okay. So there's one more thing we're going to have to change before this slider becomes effective. Does anyone want to take a guess what we have to change? Say it again in the back. Yep. So if we open up our signal source block where it says frequency 1000, just change that to the word freak. Freak referencing the variable we just created with that slider. Again, that's in the signal source block. Once you have that changed, you click OK. And then once you do that, go ahead and click your play button. And now that should open up and you get a slider either at the top of your page or at the bottom of the page. We did not define where we wanted to put that slider in the GUI, so the program is going to make its best guess. And it's not going to be consistent for everyone.
It changed.
What changed?
So when I opened up the first time before we changed the word to free, the slider was at the bottom. And now when I did that, then it started.
Yep. Like I said, it's not consistent. We didn't define where we wanted it in the GUI, so it makes the best guess. But we can tell it that we want it to take up like 1 column, 2 row. We can define all sorts of stuff with that, but we're not. So once you have this up and running, go ahead and you can drag the slider around. And you'll notice as you drag the slider, the frequency changes. So there's something I want you all to notice. Down at the bottom right of your window, there's something called FFT size, which should sound familiar from GQRX. It does the same thing here. Look at the shape of this when you leave it at default 1024. So come down to the bottom and set it to 2048. Notice how it gets sharper. Go ahead and set that even higher to 4096. And basically, the higher you go, the sharper that image will be. And if you put it all the way up to the maximum, it makes this like really straight looking line. And that's basically because you're defining the resolution bandwidth. And the way that works is, imagine an FFT display divided into multiple parts. So if we did an FFT size of 2, it would just be 2 halves of the window that would be able to go up and down. And if we double that to 4, that makes 4 parts of the window that are able to change. And really what we're doing here, right now it's set to 32,768. So that window is divided into 32,768 slices that are able to change depending on the frequency. So it's defining our resolution basically. And the higher we put that number, the more CPU utilization that you have. For this really simple flow graph, it should be pretty much negligible to your CPU. But when you start playing with radios, taking in real world samples, it matters a lot. On the third tab, there's something called a time domain display. Who here has used an oscilloscope before? If you use an oscilloscope before, the time domain display should look pretty familiar to you. Notice that there's 2 lines there. One is labeled real, which is blue, and the other is labeled imaginary. I want you to keep note of that. In a minute, we're going to go into the blocks, and we're going to change them all to complex numbers instead of real numbers. And then we're going to look at that time display again. And the second tab is your waterfall. If the computer is kind of crappy like this one, you'll notice it jumps around a lot. If your computer is absolutely fantastic, like a rock star, you should have a pretty solid line all the way across. But this computer is probably choking on my streaming software, so. And then on the last tab is something called a constellation display. We'll talk about that more in a little bit when we're messing with complex numbers. Does yours look different, Wasabi?
Mine just staggered dots.
It probably all depends on like the speed of the computer.
No, okay. I'm slightly decent.
So go ahead and close your main window. So go ahead and click each one of those blocks. You hit the up arrow when you click each one, and that will set everything back to complex. Once you set everything back to complex, so all your blocks should be blue on the inputs and outputs. Go ahead and click the play button again. So now you'll notice that your center frequency is still 0, but instead of having 2 spikes, you'll have 1 spike. And that's because with complex numbers, you have a definite negative frequency and a definite positive frequency.
I figured out what I'm doing.
Why are you different?
I'm doing different frequencies, and when I go through in the constellation display, it goes from dots to dashes.
Okay. So now that we're running complex numbers again, I want you to open up that time domain display tab. And you can kind of drag your frequency down pretty low until it breaks out like this. Now you'll notice that there are 2 waveforms there. They look almost identical, except they're offset from each other. Now, in terms of phase, we talk about phase in angles or degrees. Those are 90 degrees out from one another. So one of those signals is your real or I, and the other one is your quadrature or imaginary or your Q. If you go over to the constellation display, you'll notice now you have a circle or an oval rather than the flat line that you had before. So the size of the circle depends on the amplitude of your signal, and whether the shape of the circle is going to depend on the like the modulation type. The frequency is decided by the speed at which the circle goes around is defined by the frequency of the signal. So in the real world, when we're looking at signals, a frequency modulated signal doesn't really have much of an amplitude change going on with it. So a frequency modulated signal should just give you a circle, and you can't really see the speed of the circle changing. An amplitude modulated circle always has the amplitude changing with it. So that circle is it's not really going to be pulsing, but it's going to be like a basically a big blue field full of dots. Where it gets really interesting is the phase modulated signals or the phase shift keying signals. Depending on the number of phases that they use to make several clusters of dots. So as I was explaining to Wasabi before, if you have a BPSK signal or a binary phase shift keyed signal, you have 2 phases that you're working with, so you get 2 clusters of dots. If with a QPSK signal or a quadrature phase shift keying, you have 4 clusters. And basically the more phases that you add, the more clusters of dots that you get. So the constellation display is good for picking apart what types of signals that you're looking at. Other than that, not too much should have changed when you're looking at the waterfall or the frequency display. All right, so now we can go ahead and close that. So now we're going to start taking in real-world samples. We're going to use our RTL SDR device to take in samples and feed it into the Qt GUI display. So what I want you to do is click and drag so you highlight both the signal source and the throttle block. Once they're both highlighted, just press the delete button on your keyboard. Just like that, poof, they're gone. This Qt GUI range, highlight it, don't delete it. Instead of hitting delete, press the D, press delta on your keyboard. When you press D, it should just turn gray. That is called disabling a block. So when you would want to disable a block rather than delete it is if you're messing around with something and you think something is getting in the way, or if you're not using something but you will later, you disable the block, it takes it out of the program. It's kind of like commenting out code. You're taking it out, but you're still leaving it there. Over in your search bar, I want you to type Osmocom. Does everyone have an Osmocom sink and an Osmocom source? Does anyone not have an Osmocom sink or source?
How do you spell?
Yep. So did you guys? Yep. So did you guys compile your GNU Radio from source? No. Okay. Are you using Ubuntu? Yeah. What do you use for your package manager? All right. Sudo apt-get install Osmocom. If you just type Osmo and hit tab, you'll be able to figure it out from there. All right, so using what we learned so far, if our RTL SDR is providing samples to the diagram, do we want to use a source or a sink? Yep. So go ahead and click and drag your Osmocom source into the flow graph. Are you all finding it okay?
Yeah, I got it installed. Do you know how I can load it into the
You should be able to close and open GNU Radio, and it didn't load up for you.
This Osmo Attack SDR?
See, usually I compile it from source, so I know it's probably that. It should be that. I don't even know just Osmo was a thing. I'm not even sure what that does. If you hit tab, if you do double tap tab, what's that come up with? Is there a lib Osmo something? Lib Osmo SDR0, try that. And your GQRX is working fine? I'm surprised because GQRX uses the Osmocom SDR package for the basically.
Gnu Radio just doesn't. It's not pointed to the correct place. It's not included.
Oh.
See if I can find it.
All right, so for those of you that have the Osmocom source on your screen, double-click it to open it. Notice your output type, complex float 32, you can't change that. Any SDR device that you encounter, or most SDR devices that you encounter, have IQ signals or complex numbers. So they're always going to feed complex numbers into your GNU Radio diagram. The device arguments, you should be able to leave blank. If you have multiple SDRs plugged into your computer, you'd use that to define whichever SDR you wanted to use. If you have like a hack RF or something that can take multiple options, you could put those in device arguments as well. All these sync, number of boards, all that stuff, you can leave default. When you come down here to samp rate, we don't want to put audio samp rate there. Anyone know why? Because your RTL SDR does not really do very well at 48 kilohertz. And at 48 kilohertz sample rate, you're also not going to be able to pick up an entire FM radio station within that bandwidth. So what we're going to do is first we're going to come here, we're going to define RF underscore samp rate. And just hit OK. Now it's still not going to be happy. Now if we just take our variable block, right click, copy, then we just hit paste. So now we get a second variable. And instead of calling it audio samp rate 0, take that underscore 0 off the end and change the word audio to RF. And now for the value, we're going to use 2.4 E6, or that's basically saying 2.4 million. You could also, if you really wanted to, you want to type a whole bunch of zeros, you could do 2400000, but I think you'd rather type 2.4 E6 than all those zeros. I somehow broke something here. Number of channels, 1. So everybody have a variable named RF underscore samp underscore rate with a value of 2.4 E6 or 2.4 million or 2400000. All right, I'll take that as a yes. So now go ahead and click the output of your Osmocom source. Click the input of your QT GUI. Now there's one more thing we need to change in here. Does anyone want to take a guess what that one more change is? Yep. So someone said audio sample rate in the QT GUI. That is correct. We don't want that to be audio sample rate anymore. So in GNU Radio, the sample rate out of one block has to match the sample rate into the next block. So since the sample rate of our Osmocom source is 2.4 million, the sample rate of our QT GUI also needs to be 2.4 million. So we'll just put RF samp rate instead of audio samp rate and click OK. From there you should be good to go. Click the little play button. Give it a second to load up. And you should get something like that. Say it again? Re-enable what? You don't re-enable the slider. We don't need the slider yet. Excuse me? Having trouble?
Yeah, with this one. It's just red still.
Number of boards? Should be
One.
one.
Okay. Okay, yeah, that's what it looked like. His looked like too. Just hit apply.
Yep.
Thanks, sir.
You say the frequency 2.4?
Not the frequency. Leave that at default. Put that back to 100. Oh, you got 2 blocks there, Roger. Let me help you out here. Click OK on that. Click OK. Click. All right. Highlight that one. Press delete on your keyboard. Or, yeah, that's fine too. Not delete. Delete. All right, so now right-click the variable audio samp rate, right-click copy, right-click and anywhere on the screen, and click paste. Now double-click it. Now take the, no, go back general. Take the _0 off the end of it. Now go to audio and highlight audio and just backspace. Highlight the audio and hit backspace. ID, audio. Highlight that and hit backspace. Now do RF _. Now the value 2.4E6. Yep. E6. Click OK. You could just hit OK and it automatically applies it. All right, now click play button. All right, you can go ahead and make that full screen. Yeah. Awesome. So go back over to your frequency display. So notice when you change FFT size, that becomes like a little bit more, it's able to see more frequencies, like resolution bandwidth.
Got it. I can actually discern the difference between them.
Yep.
Okay. To the point where, okay, now it's kind of like a moving wave.
All right, you all doing okay?
I think so.
All right, awesome. Anyone back here having trouble?
I haven't done this before. I haven't played around with this. Had a frequency slider at the top.
That's a few steps away. Jumping ahead of the class there, Verity. What is this?
USRP.
Ooh, fancy. All right, so now everyone has this display, so we're going to move on to the next step. So it works. Congratulations. Now we're going to add more stuff. Go ahead and drag that Qt GUI sync out of the way. We're going to put more stuff in line with the Osmocom source block. So now what we want to do is we want to be able to get some sort of audio, right? We want to hear the FM stations. So for that, we're going to need something called an audio sync. And as soon as you type audio, it should be the first result, audio sync. Just click and drag that into the diagram. Double click that. Now where it says samp _ rate, you can either change that to audio _ samp rate, or you can click the drop down menu and click any of the compatible sample rates for your sound card. Now since we already have an audio samp rate variable, we'll go ahead and use that. Device name, if you have multiple sound cards, that's where it helps out. It'll help you out there. OK to block. Basically, does it tie up your program? Does it tie up your CPU? Yes, it's OK. Just leave that be. Number of inputs, just leave that at 1 since we're not doing stereo. And click OK. Now I want you to notice something. See how audio sample rate is still not happy? See how it's still red? This block for the sample rate, it's expecting an integer. Now for you programmers out there, this variable block, when you use this E6 value like this, it creates a float by default. But this is Python on the back end, so we can use Python to tell it, no, I want this to be an integer. And if you just open up your, we're going to do this both the RF sample rate and the audio sample rate. Actually, I'm going to hit cancel. We'll come back to the RF sample rate in a bit. So open audio sample rate. So in front of the 48E3, type int, and then open parenthesis. And then at the end of that, put a close parenthesis. That's in the value. There should be int, open parenthesis, then the 48E3, and then the close parenthesis. I'll leave that up for a little bit. What does it look like? Yep, we're in the variable audio sample rate. So now when you click OK on that, notice the value still says 48K. But now you come over to the audio sync, now suddenly that is happy. It says sample rate 48K. It's not airing out anymore. The only error that it's having right now is that there's no input there. So we're going to need another block that takes in that RF and turns it into some sort of useful audio. And since we're using wideband FM in this situation, or WBFM, if we type WBFM up there, you should see a few different WBFM blocks. We are interested in WBFM receive. So drag and drop WBFM receive into your diagram. Now you'll notice a couple of different things here. We got a quadrature rate, which is the input sample rate of the block, and the audio decimation, or how many times do we have to divide the input rate to get down to 48K. So we're going to leave those blank for now. We'll come back to that in a bit. So in GNU Radio, you never want to work at sample rates faster than you have to. Does anybody know what the bandwidth of a wideband FM channel is? Yep, 150 kilohertz for a wideband FM channel. So we're going to sample a little bit higher than that. We're also going to sample at a rate that makes math much easier. So we're going to downsample this to 192 kilohertz. And we're going to do that with a block called a rational resampler. So if you type in rational up in your search bar, the second result is a rational resampler. Go ahead and click and drag into your diagram. You can go ahead and connect the output of your Osmocom source to the input of the rational resampler. Double click that to open it. So now there's a couple things there. The bottom two things, the taps and the fractional bandwidth, don't worry about. The first thing is interpolation. And interpolation is basically adding in samples. So if we want to interpolate by 2, it's essentially doing a multiply function. So if we were if we had a sample rate of, say, 20 kilohertz, and we interpolated it by 2, on the other side of that, we would get 40 kilohertz. And then the other thing there is decimation. That's the same as dividing or removing samples. So if we had that same 20 kilohertz sample rate and we were to decimate it by 2, we now suddenly have a 10 kilohertz sample rate. So by default, they're both set to 1, so the block would be useless if we kept it at 1. So we're not interpolating, we're decimating in this case. However, we can use the math to our advantage here, and instead of trying to figure out, well, we got to divide 2.4 million by 192. So doing all that, we can do interpolate by your RF sample rate, and we're going to decimate by our IF sample rate, which we did not define our IF sample rate. In the radio world, IF stands for intermediate frequency. So in an analog radio, let's suppose you tune into, let's suppose you turn into 99.1 FM. It's not working with that 99.1 megahertz through the whole radio. It mixes it with another signal, and you get an intermediate frequency of, say, 10.7 megahertz or something like that. So here we're going to have a intermediate sample rate. For now, we'll just hit OK on that. We'll leave the IF sample rate alone. We'll take this RF sample rate block. We'll again copy, paste. Again, take the _0 off the end. In the beginning, instead of RF, I'm going to change that to IF. And we want our intermediate sample rate to be 192,000 or 192 E3. But not just 192 E3. We want that to be an integer of 192 E3. So go ahead and just type int, open parenthesis, 192 E3, close parenthesis, in your IF sample rate block. I'll give you all a minute to do that. All right, so everyone has a variable named IF sample rate with an integer of 192 E3 or 192,000. All right, click OK on that. So you'll notice that the decimation block became happy. However, interpolation is still not happy with RF sample rate. Anyone know what we have to do to make the RF sample rate happy in that block? Yep, open up your RF sample rate and also make that one an integer. Now we can define it as an integer there, or we can define it as an integer in the block. But just like using variables in any other programming language, it's helpful to just define it in the beginning, and then we don't have to worry about it everywhere else. So now that we have that all fixed, open up your wideband FM receive block again. We're going to fill in that quadrature rate. So who knows what the quadrature rate of this block would be? If the output of the block before it is outputting 192,000 samples per second, then the input of this block should also be 192,000 samples per second. So, or we just define that as IF underscore sample rate. So that's one part that's made happy. The audio decimation. So we could either figure out ourselves mathematically that 192,000 divided by 48,000 is some number, or we could just let the programming do the math for us. And we'll just do IF samp rate divided by. So now we do IF samp rate divided by audio samp rate there, and it should come up with a number like 4 or something along those lines. So I'll just leave that open for people to see. I'll click apply. Yep. So when you click apply on that, you should get quadrature rate 192K and audio decimation of 4. Now, why would I not just want to type 4 in that audio decimation spot? It's really easy. One keystroke, 4, done.
So if we change anything, it'll do the math for us.
Yep. Because just remember, underneath GNU Radio is just Python, so why do work that the programming could do for you? So we'll click OK. So now you can connect up the wideband FM receive to the audio sync. Now there's one more thing I want to add in here before we start trying to run this diagram. Now remember I said that a wideband FM channel is 150 kilohertz, and we're feeding it 192 kilohertz of bandwidth. So we want to filter out some of that extra noise. So we're going to add something called a low pass filter. And as soon as you type low underscore P, or low space P, I'm sorry, it should come up with a low pass filter block. So in GNU Radio, what a low pass filter does is it not only, so a low pass basically lets you all your lower frequencies through. So we're going to define some cutoff, so everything above that cutoff gets passed through. It not only works on the positive half of the frequencies. Remember how we had positive and negative frequencies? So it doesn't just work on the positive side, or it doesn't just work on the negative side. It works on both the positive and the negative side. So we're going to define the cutoff frequency as half of the channel width. So see how that says samp underscore rate right now? So if the block before it is 192K and the block after it is 192K, what should we make this block? Yep, IF samp rate or 192K. So now the cutoff frequency, remember I said it's going to be half of our expected channel width. So half of 150K is 75. So we're going to do 75 E3, or you can type 75000, up to you. Transition width. So do we want this filter to be perfectly sharp, or do we want this to have some sort of smooth roll-off? The answer is it depends, mostly on your CPU. How much CPU do you have to spare? The sharper you make that filter, the more CPU time that filter is going to take up. If we just put 5E3 in there, or 5,000, that's a perfectly good number. That'll work perfectly fine. It shouldn't bog down anyone's CPU in here. If we made it a transition width of 0, even some of the faster computers would choke on that. Everything else you can leave at default. So again, sample rate, IF samp rate, or 192K. Cutoff frequency, 75E3, or 75,000, or half of your channel width. And transition width, just so it doesn't bog down your CPU, you could put at 5,000 or 5E3. Click OK. Connect the output of the rational resampler to the input of the low-pass filter. Output of the low-pass filter to input of wideband FM receive. Once you do this, you should not have any red in your diagram. So when you go to click the play button on this, what do you expect to hear?
Somebody's static because they didn't bring headphones.
That's a snarky answer. It's a good snarky answer. I like that, Wasabi. But yes, he included the right answer in that. We expect to hear static when we go to turn this on. And that's exactly what we're going to do, is we're going to turn this on and listen to static for a second. Anyone want to take a guess as to why we hear static and not some sort of radio station? Yep, we did not tell it to go tune to any sort of frequency at all. And right now, our demodulator is looking at this 0 megahertz, or the center line, which this 0 megahertz we're also going to change in the next few steps. So, once you're tired of listening to static, go ahead and close that.
I returned snarky remarks and snarky remarks.
So once you close that, go ahead and open up your Osmocom source block and look at your channel 0 or CH0 frequency in hertz. By default, that is set to 100 hertz. Now, for now, just for funsies, we're going to tune it, just going to set it to a station that we know works. Now, instead of typing all those zeros afterwards, again, you can use your little E6 trick. And E6 is basically the same as saying mega. And I know for sure that 99.1 E6 or 99.1 megahertz is a pretty strong FM station that is going to come through clearly. So we'll hit OK on that. And I'll open this back up just so you can see it. Channel 0 frequency in hertz, 99.1 E6. Anyone having trouble finding that? Cool. Okay. And then once you do that, just click play. And I should hear something. I am getting a lot of audio overruns. It might be because I am using the streaming software. So when you guys go to click and play that, does anyone else get this at the bottom of their screen? Or do you actually hear something?
I do get that. And I hear something.
Okay. This worked before, I swear.
It's a ghost sending you a message in Cheerios.
Is it really Cheerios?
Yeah, it says, ooh.
Oh, I found the problem.
Yes.
I did something backwards. Does anyone know what I did backwards in this diagram?
Something says RF instead of IF.
The low pass filter should come after the receiver, not before.
Actually, it goes before.
Register and your decimation, you get them backwards?
Not these.
Low pass should go before the resampling.
Nope.
Okay, just tell us.
All right. So rational resampler, why did that come up on my screen? So the rational resampler, I put RF sample rate on top and IF sample rate in the bottom.
Oh.
So change those around. So now you should be interpolating by your IF and decimating by your RF. Hit OK. There we go. And that would work well on this machine if I wasn't running the streaming software at the same time. So I'm going to close that because it just sounds awful. So I wish I could have it playing, sounding all pretty, but this computer can't walk and chew gum at the same time, so. Is anyone getting clean audio out of that? Cool. Huh? Cool. So I'll let you all play with that for a minute. Well, I don't know if there's anyone that needs to catch up, anything like that.
You're forcing me to listen to politics.
Yes, I'm forcing you to listen to talk radio. I'm sorry.
So we need like all these blocks for each time we want to like output FM to audio. Is there a way to like just save all those blocks so you can just drop 1 mega block each time, or do you have to set that up each time?
You have to set that up each time, or you just you can copy paste from one flow graph to another.
Okay.
And there's also a couple other blocks that can be combined, like in the rational resampler, that taps value you can put in the string of text that the low-pass filter creates into that. But the downside of that is you can only either interpolate or decimate. In that case, you do both, so you don't have to do some of the math on your own. So there are shortcuts, but for simplicity to class, we're doing it this way. All right, when you're done listening to talk radio, all right, but now we're going to make it here so you can change the radio station on the fly. So what I want you to do is open your Qt GUI range back up. Now instead of default value of 1000, set the default value to your favorite radio station. I'm going to be lame and set it to the talk radio station because I know it works. Now the start and stop values, that's going to be the start and stop of the wideband FM band, of the wideband FM broadcast band. Does anybody know where the wideband FM broadcast band starts and stops?
Like 81 to like 105.
So I heard someone say the right things, or a combination of you people eventually came up with the right thing. So it starts at 88.1 E6, and it stops at 107.9 E6. Now step of 1, no, not going to do step 1. Does anyone know the channel spacing or the step in between each radio station? Yep, it's going to be 200 kilohertz, so that's what we're going to put first step there. It's 200 E3. Or you could do 200,000, or you could probably do 2 E5 if you really wanted to.
How do I turn it back on?
Okay. So now you'll still notice something about your freak block. It's still grayed out. So before you hit D to disable it, now you're going to hit E as an echo to enable it. Again, just hit E as an echo, and that will enable your frequency slider block, or your Qt GUI range block again. So now that our freak value is once again defined, open your Osmocom source, and where you put the 99.1 E6 earlier, you're going to put in freak, or FREQ. Hit OK. Let me turn off.
Never mind, I'm good.
Once you do that, go ahead and click play. So now you should have the ability to tune around 2 different radio stations.
What was that last step that you did? Just enable the block?
Oh, so your Qt GUI range, you press E as an echo to enable it. And then don't forget to, in your Osmocom source, under channel frequency, put freak there instead of the hard-coded number. So when all is said and done with, you should have the ability to tune around and find different radio stations.
Can you open up your QT Gnu Radio box? I just want to see something. Okay, I see what it is.
What?
The default value, I didn't put the E6 at first. I thought I was following the deal.
Oh. No, I said I was going to be lame and put 99.1 E6 as like my favorite radio station default.
I think I did away.
Oh.
But I'm good now.
But the default value can be pretty much whatever radio station you want it to be. It's just.
So I didn't put the 6 at the end of my radio.
I know.
So it's like,
I'm just trying to not give you too much crap for it.
I don't care. I live on radio.
Someone had a question? Okay.
How low can you start going? How low can you put?
As technically as low as you want. I put it at 88.1. 88.1 E6 is low because that's the bottom of the wideband FM broadcast range. If you use wideband FM receive below that, you're probably not going to pick up much as far as intelligible signals go. But GNU Radio, you get to play with the numbers in any way that you please, and you can do all sorts of really awesome stuff with it that goes far beyond the scope of this class. Now notice how a FM signal makes a circle in the constellation display. You find a good radio station you like, Wasabi? You okay?
What's your FFT set for?
1024.
Yeah, mine's not a circle, it's just like a block.
Zoom in. Zoom in a little bit. You can drag a square on your window.
Oh no, like
Right click. You just right click it goes back to. And then I can. Yeah. Yeah, it's like a it's a sort of see how it's like a donut shape.
well, let's see if my box actually switches over to the backup battery.
Did you change the x-axis separate from the y-axis?
It just depends on the shape that you. So see how it makes like a rectangle when you drag. It just depends on the shape of that rectangle. For like if I made a tall one like this, it makes it more squished. Or if I make like a flat rectangle, it makes it more circular. You're literally telling it to zoom in on a particular spot in a particular way, and it just goes. Now, if that was a PSK signal, you would see 2 separate clusters or 4 separate clusters, depending on the kind of PSK. And then AM, that would just be this blob that kind of like pulsates and.
Quick question.
Yes.
I'm tuned in and the audio sounds fine, but I notice my constellation looks a little bit different.
Yeah, it's kind of a fun. It's like in my
Oh, really?
I guess it depends on. things. I don't know. It's also going to depend a lot on like the strength of the receive signal. So I'm on 99.1, which is a very strong station. So that's making a very defined circle. Where if you're on one of those signals like way down in the noise, it's going to be a much tighter circle.
So, Corey,
Yeah.
when I build these things and they save the file down, do I just then at a future date just double click that file
You could double click that Python file. Yep.
and it'll just like launch the app, or does it have to open up the entirety of Gnu Radio?
Nope. That's how when I run the flags for the CTF, I use that no GUI option, and I make a script that just calls each one over and over again.
So the no GUI option, and then you just run it from command line?
Yep.
Alright, well these.
One day you can make stuff that like hurts your head to look at. And that's that generates a BPSK signal. And then
Showing off.
yep. Yep. No. It's not that fancy.
It puts up the bat signal in the sky.
Just the forward error correction part of this, I beat my head against that for like 4 hours straight before it finally did what I wanted it to. But baby steps, start with stuff like this first.
That's gonna be some cool ideas.
What's your cool ideas, Wasabi?
I'll have to share offline.
Okay.
It's for CTF.
Yeah, and then Gnu Radio has all sorts of different blocks that you can download separately. Like there's some that decode GPS signals, or some that decode GSM type stuff. I can't read lips. I'm sorry. I don't know about Wi-Fi blocks. Have you seen them? Do they exist?
I'm trying to find them.
Good luck. I don't think they do. Yes.
There are a couple open source projects to do 802.11 and Gnu Radio. The issue is the computing required, because you're looking at 20 to 40 megahertz with the bandwidth at a time to do it. And it's no FDM, so there's a lot of FCPs and everything. So really, what people are moving to is just do it on the FPGA, actually on the there's just too much. You can't do it fast enough to keep up in real time. The best the open source ones can do is receive packets individually, but you can't actually have a transaction with another device. You're too slow.
I'm not trying to do a lot.
Okay. Yeah, you can send basic 802.11 frames with the open source ones with the right hard.
Just say the,
Bless you.
the active is just 2 megahertz.
You know what the names are of those projects?
It's like, I think there's a GR 802.11.
Don't get me started.
Yeah, but there's a couple of various stages.
And so now if you use this flow graph as like a basic building block, there's all sorts of stuff you can add to it. Like if you open up the Osmocom source, you'll notice that there's like the RF gain, the IF gain, and the baseband gain. I forget which one controls the LNA on the RTL SDR dongle, but you can add a slider in there that adjusts the LNA gain. I know on the HackRF all 3 of those sliders do something. I just don't remember which one specifically helps on the RTL SDR. You could add in other filters. You can make other receivers. You can make a stereo FM receiver, which stereo FM is like a whole nother topic of its own.
I'm curious.
Does anyone here actually use Gnu Radio to do something else besides this sort of stuff?
What do you mean?
One?
What do you mean this?
Say again? But like just like a basic wideband FM receiver type thing. Have you done anything besides that?
Okay.
What have you done?
Probably did. I was using it to basically sniff the keypad transmissions for a car.
Okay. Yeah, that's a pretty common word. Like you can get the raw like 1s and 0s out of that.
So there's a good one where a guy figured out the signal for the coasters at restaurants, and he figured out what he could transmit to turn all of them on.
That'd be pretty good. I'd love to go to Olive Garden one day and do that. That'd be awesome.
So some of them you have to do weird shit to because they actually are like geo blocks. If they get too far from the base station, they go into a weird mode.
Really?
There's a YouTube video on it. Like you could,
There's YouTube videos and everything.
yeah.
Speaking of YouTube videos, there's plenty of other YouTube videos related to the GNU Radio. All of Mike Osmond's videos, so remember the homework from week 1 where you had to watch that video. He has a whole series out there that goes over all sorts of fun stuff. And do you have a question or are you being an antenna right now?
Oh, sorry, I was not being it.
Okay. No.
This is way better than that. It's just
Why? Ah. No. Wow. All right, so your homework for something for you to look into for the CTF. How can you use your RTL SDR dongle for its original intended purpose? Basically, how can you receive TV signals with it? Specifically on Linux, because it'd be different instructions for Windows and Linux. There was more homework than that, but somehow LibreOffice just like crapped out and erased the last half of my slide. I guess not. I don't even remember what the other things were, but I promise they would have been helpful for the CTF next week. Does anyone want to come in like really early for the CTF and have like a little cookout, do a barbecue sort of thing? Burn some burgers, hot dogs. Next week, Tuesday. But we need like a general consensus, because if it's like 3 of us here at 6 o'clock eating burgers and everyone else rolls in at 7, then it's like, what's the point? What's that?
Bring your own meat.
Yeah.
I always bring my own meat.
Are you willing to do it?
I'll share it.
Yeah. So someone had a good point, like bring your own meat or bring your own stuff for the cookout. Yeah, bring your own meat and buns. I'll make sure the grill works by then so you can actually cook stuff. Just an idea of how the CTF is going to work. So you're going to come in, you're going to set up your stuff just like you are now. I'm going to have a bunch of stuff up here just transmitting stuff out there. I'm not going to tell you what frequency it's on. I'm not going to tell you what mode it's using. You basically got to figure out basically by repetition and by SIG-ID wiki or your own experience, figure out what the signal is and what it says, and then there's going to be a little web page you go onto. You copy paste whatever text you get into that web page, and that web page is going to tell you you're either right or wrong. And if you're right, you get points, and if not, then try again. Yes.
So you were saying like you should hear the back end of your Gnu Radio thing. Did you do like a sweeper? So in other words, it would automatically leave Gnu Radio thing like a sweep, so we start this frequency, this frequency. Yeah, there's a triangle thing.
Yeah, I'm sure there's probably a way to do that. I've never done it myself.
No, but I mean, if you want to play around with it, you get practice.
Yep. Yeah, you're more than welcome to do whatever you need. There's no disallowed tools. You could bring in an entire like $5,000 setup if you wanted to. I'm not stopping you. So basically do what you need to find the signals, figure out what they are, decode them, and get points. And the incentive for the points are if you get first place, you get an air spy with a spyverter. Second place, you get just an air spy. Third place is one of those RTL SDR dongles, metal ones with the antennas. And then I'm working on getting some like an adapter kit to go with it too. So come in, earn points, get prizes. Other than that, have a good night. Thank you for coming out.
Thanks, Corey.
No problem.
Can you send out the signal what you did last week?
Say it again?
Is that easy? Can you send out the signal for my work? What you did, whatever you did last week?
The C-SPAN TV signal.
Yeah, oh yeah. Give me a minute to set that up because I don't have any of that running right now.